Good evening everyone. Today we are going to discuss about the mechanism of glomerular filtration. This is an important essay question for you. The glomerular filtration occurs through the filtration barrier. The filtration barrier contains three layers. First one is the endothelial cells of the glomerular capillaries, and next one is the glomerular basement membrane, and third layer is the epithelial cells of the visceral layer of the Bowman's capsule. This forms the projections called food process. This food process forms the third layer of the filtration barrier. So see this, between the endothelial cells, the space is called the fenestra, and between the epithelial cells, the space present between the epithelial cells is called the filtration slit. Through these spaces, the plasma gets filtered and form the ultrafiltrate in the Bowman's capsule. Okay, now let's see the capillary permeability. This is the endothelial cells. Between these cells, the fenestra is present. The substance is less than 4 millimeter gets filtered through this fenestra. The substance more than 8 nanometer will not get filtered. And see, these three layers are negatively charged. The substance like albumin, though the albumin is less than 4 nanometer, it gets repelled back because it is positively charged. Okay. The glomerular filtration mainly has two major factors. First one is the pressure gradient and next one is the filtration coefficient. There are two pressure gradients. First one is the hydrostatic pressure and next is the osmotic pressure. The filtration coefficient depends on the size of the capillary bed, that is the surface area of the capillary bed, and next one is the capillary permeability. You already know the capillary permeability depends on shape, size and charge of the filtration barrier. That is the capillary membrane. Next, you have to know about the net filtration. First, you have to know the pressures present in the glomerulus and the Bowman's capsule. First one is the hydrostatic pressure present in the glomerular capillary is 45 mmHg. So, the hydrostatic pressure from the afferent arteriole and the hydrostatic pressure in the efferent arteriole remains the same, that is 45 mmHg. So this hydrostatic pressure is a positive pressure which helps in the filtration of the plasma. This is the positive pressure. Okay. Now let's see. This is the positive pressure. So PGC. Okay. And this is the hydrostatic pressure in the Bowman space. So this pressure opposes the filtration. So this is the negative pressure. So minus hydrostatic pressure in the Bowman's capsule. Okay. Next is the oncotic pressure in the glomerular capillary. The oncotic pressure in the glomerular capillary is due to the plasma proteins present in the glomerulus. This plasma protein opposes the filtration. It does not filter through the filtration membrane. So it opposes the filtration. So this also a negative pressure. So minus pi Gc. So the oncotic pressure is denoted as a pi in the glomerular capillary. Okay, this is the negative force. So minus pi. And the oncotic pressure in the Bowman space is a positive charge, positive force. So away from the capillary membrane. So this is the positive force. So plus pi Bc. Okay, now you clearly understand how this formula comes. So now you have to know the hydrostatic pressure in the afferent arteriole is a 45 and the hydrostatic pressure towards the efferent arteriole is also 45. But the oncotic pressure from the afferent arteriole is 25. So when the plasma gets filtered through the filtration membrane, the oncotic pressure increases towards the efferent arteriole because the plasma proteins gets concentrated. This plasma proteins exert the more pressure towards the efferent arteriole. So, towards the efferent arteriole, the oncotic pressure gets increased to 35 mmHg. Only the oncotic pressure changes from the afferent arteriole to efferent arteriole, but the hydrostatic pressure remains the same in afferent arteriole and also in the efferent arteriole. Now see the glomerular filtration rate. You already know net filtration pressure. The glomerular filtration is equal to filtration coefficient into net filtration pressure. So net filtration coefficient and substitute the formula of the net filtration pressure. The filtration coefficient depends on the surface area, size, shape, charge of the substance of the filtration membrane. So, this filtration coefficient is already determined as 12.5 meter square per minute per mm of Hg. So now the glomerular filtration rate is equal to 12.5 into and substitute this value. So see, this is the hydrostatic pressure in the glomerular capillary. This is the 45 and this is the hydrostatic pressure in the Bowman's capsule. This is 10. Okay. And the oncotic pressure in the glomerular capillary 25. First you have to substitute this 25 only, okay? Because this oncotic pressure causes the filtration. So to calculate the glomerular filtration rate, this 25 mmHg only substituted. So 25 plus pi BC already know, this is 0. So 45 minus 10 is 35 minus 25. So 12.5 into 10 is equal to 125 milliliter per minute. So the glomerular filtration rate is equal to 125 milliliter per minute. What is the glomerular filtration rate? The filtration happens, the glomerular filtration rate is defined as amount of filtrate formed by glomerular filtration membrane of both the kidneys in a unit time. Okay, this is the glomerular filtration rate. Okay. Now the net filtration pressure in the afferent, you have to calculate the net filtration pressure in the afferent arteriole and net filtration pressure in the efferent arteriole. So first one, we have two formulas. We have two methods to calculate the net filtration pressure in the afferent and the efferent arteriole. So first, you have to first explain the first method. First one is the afferent. In the afferent arteriole, the outward forces is calculated, and in the afferent arteriole, inward forces is calculated. So this difference between the afferent inward forces and outward forces forms the net filtration pressure. Okay. First, you have to calculate the outward forces, means positive forces. Okay. Now see, what are the positive forces? This hydrostatic pressure is a positive force too. Okay, towards the membrane, and this one is the positive pressure. This and this, because these two in a same direction. Okay, this two forms the positive pressure. Okay, so 45 plus 0, and in afferent artery, the same in afferent arteriole, the inward pressure. These two pressures are inward forces or opposite forces. Okay, these two are calculated. So 25 plus 10. So 10 plus 25. Okay. So it's equal to 35. So now you make the difference between this. So 45 minus 35 is equal to 10 mmHg. This is the net filtration force. This net filtration force helps in the glomerular filtration. Now the net filtration force in efferent arteriole, we have to calculate in the net filtration force in the efferent arteriole. Only this value only changed, because all these values are same. Only the oncotic pressure in the efferent arteriole only changed to 35. I already explained how this 35 comes. Okay. the oncotic pressure in the glomerular capillaries towards the efferent arteriole is 35. So this value only change. So here if you change this 35, then 35 plus 10 is a 45. So 45 minus 45 is equal to 0. So the net filtration pressure in the efferent arteriole is 0. So beyond the efferent arteriole, the filtration does not take place. This indicates the filtration does not take place beyond the efferent arteriole. Only the filtration takes place when towards the efferent, from the efferent arteriole towards the glomerulus and towards the Bowman's capsule. So another method, this is a very simple method, net filtration. You can calculate from this formula. Net filtration pressure in afferent arteriole. You already know pi Bc is a 0, it's negligible. So this formula can be substituted like this. So you can substitute these values. Pi Gc is 45, PGC is 45, PBC is 10, minus pi GC is 25 in afferent arteriole. This is the oncotic pressure in the afferent arteriole. So this becomes a 10 mmHg. Then in efferent arteriole, this 25 is substituted as 35. Just simple. So 35 minus 35 is equal to 0. This also easy method to calculate the net filtration pressure. Next, you have to know the filtration fraction. The filtration fraction is equal to is a ratio of the glomerular filtration rate and the renal plasma flow. Okay, so you already know glomerular filtration rate is 125 ml per minute. The renal plasma flow is 600 ml per minute. Okay, 600 ml per minute. So 125 divided by 600 is equal to 0.20. So the filtration fraction is approximately 16 to 20%. So this is the percentage of the filtration formed by the glomerulus. Okay, well, this is the filtration fraction formed by the glomerulus. This is the percentage of the glomerular filtration rate. Next, see the factors affecting glomerular filtration rate. First one is a change in renal blood flow. If there is a decrease in the renal blood flow, there is a and also decrease in glomerular filtration rate. Next is the glomerular capillary hydrostatic pressure. If the afferent arteriole constrict, the hydrostatic pressure also decreases. So, and this leads to decrease in the GFR. Okay, when the when the afferent arteriole dilates, the hydrostatic pressure increases. This increases the glomerular filtration rate. Okay, change in capsular hydrostatic pressure. If there is any obstruction in the Bowman's capsule, the capsular hydrostatic pressure increases. This causes the decrease in the GFR. Okay, because this is the negative force. Okay, then oncotic pressure, in hypoproteinemia like conditions, the proteins are decreased in the plasma. So if the protein is decreased, the GFR is increased. Okay, so then see the capillary permeability. You already know if the capillary permeability increases, GFR is also increases. And next come to the effective filtration surface area. Effective filtration surface area. The size of the filtration area depends on the mesangial cell. If the mesangial cell constrict, the glomerular filtration decreases. If the mesangial relaxes, the surface area is increased, the glomerular filtration is also increased. Now, you already know shape, size, and electrical charge of the molecule also determines the glomerular filtration rate. Okay, these are the factors affecting the glomerular filtration rate. Okay, that's all my topic. Thank you.